Now here, in this video, we'll be solving some past paper questions based on factorization. This is one of the questions that came in past papers. It says factorize completely. Now, in my previous video, I've explained the 4 different types of factorization. So if you don't know factorization, please refer to that video first. And then you can easily understand these past paper questions being solved. Now, in the very first part, we have yp plus yt plus 2xp plus 2xt. Here we can see there are 4 terms. So whenever you have 4 terms, you always go for grouping. And when you go for grouping here, you look for the first 2 and the later 2. For the first 2, you can see y as common. So y taken common. First term would be left with p. And the second term when y taken common would be left with t. For the later 2 terms, you can see 2x is common. So 2x when taken common, first term would be left with p, second term would be left with t. Now for these 2 terms formed, you can see p plus t is common for the 2 terms. So you take p plus t common here, p plus t when taken common. The first term would be left with y and the second term would be left with 2x. So we have got the factorized form. Part B. This is 7h plus k whole square minus 21h plus k. Now here we have been given with 2 different terms. In the 2 different terms, what you can see common is, here we have h plus k common for the 2 terms, and 7 and 21 have 7 as common. So for these 2 terms, you cannot apply the identity. As I've told you earlier, for 2 terms, either it's a case of common or identity. You cannot apply the identity because both the terms are not having the perfect squares. So what you can do is you can take common. So 7 being common as a number between the 2 terms, and h plus k, a factor common between the 2 terms. So as a whole, you take 7h plus k common. The first term would be left with only h plus k. Second term would be left with minus 3 because you have already taken 7 common out of it, h plus k common out of it. So it will be only left with minus 3. So this is the final answer, 7 into h plus k into h plus k minus 3, and this cannot be simplified further. Let's pick up one more example here. Again, a past paper question. Now this question has 3 different parts. For the first part, this is m cubed plus m. Now m cubed plus m, as I've said earlier, the correct order is you look for something taken common, you look for identity, you look for middle term, and last you look for grouping. So here there are only 2 terms. So 2 terms means either it's a case of common or the identity. You cannot apply the identity here because the 2 terms are not having the perfect squares. You can simply take m common. So m when taken common, first term would be left with m square and second would be left with 1 only because it has only 1 m and you have taken common outside. So this is a factorized form for the first part. Part B, 25 minus y square. Again, we have 2 terms here, and for these 2 terms we cannot take anything common, but the two terms what we can see are the perfect squares. 25, it's a perfect square of 5. And y square is the perfect square of y. So we have got the a square minus b square form here. And whenever we have a square minus b square form, we always go for a plus b into a minus b. So its factorized form would be 5 minus y into 5 plus y. Part C, x square plus 3x minus 28. So we look for common here at first. X square plus 3x minus 28 is not having anything common. So the next thing what you look for is, for three terms, you look for is the middle term break method. And the middle term break method to be applied, the technique is you multiply the coefficient of the square term, which should be 1 here because there is no number written here, so by default it's a 1, with minus 28 being the constant. So 1 into minus 28 gives us a minus 28 only. So you now look for all the possible factors for minus 20. So 1 into minus 28, that's one possibility. Minus 1 into 28, that's second possibility. And for minus 28, the other possible factors are positive 4 into negative 7, negative 4 into positive 7, and then we have 2 into 14, negative 14, negative 2 into positive 14. Now, out of all these factors, the middle term can be broken down as minus 4 and 7, because minus 4 and 7 when added gives us a positive 3. So middle term would be broken down as x square plus 7x minus 4x minus 28. And now you look for taking common. For the first two terms, x is common, so it would be x plus 7. For the later two terms, it's minus 4 common. So again, x plus 7 is there. And finally, x plus 7, it's a common factor for the two terms. So x plus 7 would be taken common now. It would be x plus 7 into x minus 4. Let's pick up one more question about factorization. Now here again the question says factorize only. So for factorize, we have to keep all the four techniques in mind. The first part is 2mn plus m square minus 6n minus 3m. And there are four terms here, and whenever we have four terms, it's always the grouping. So here, for the first two terms, you can see m can be taken common. So m taken common, first term would be left with 2n, and the second term would be left with m only. For the later two terms, we can see minus 3 to be taken common. Minus 3 when taken common, it would be left with 2n, and the next term, when minus 3 taken common, it would be left with only m. And 2n plus m, it's a common factor for the two terms now. The 2n plus m taken common, first would be left with m, second would be left with minus 3. Got the factorized form. Part 2. 4y square minus 81. 4y square, that's a perfect square of 2y. 2y whole square. And minus 81. Minus 81, it's a perfect square of 9. So to factorize them, we'll apply the identity here. which is a square minus b squared. So it would be a minus b into a plus b. Its factorized form would be 2y minus 9 into 2y plus 9. Third part, t square minus 6t plus 8. Because of the three terms, we'll see if there is anything common here or not. For the three terms, we cannot see anything common here. So when there is nothing common, you look for the middle term break method for three terms. And for middle term break method, coefficient of the first term, it's a t square, 2 is t square, coefficient is 1. And the constant term, which is 8. So 1 into 8, it's a positive 8. Positive 8 can be obtained as 1 into positive 8, negative 1 into negative 8, positive 2 into positive 4, negative 2 into negative 4. And then you look for all these factors when it should give us the middle term. 1 plus 8 gives us a positive 9, so it cannot break the middle term. Minus 1 minus 8 would give us a negative 9, again cannot break the middle term. Positive 2, positive 4 would give us a positive 6, not possible. Negative 2 and negative 4 gives us a negative 6. So it break the middle term as negative 2 and negative 4. So t squared minus 2t minus 4t plus 8. And here again we look for the common for the first one, the later two. For the first two, t is common. It would be t minus 2. For the later two, it's minus 4 common. So here again it would be t minus 2. Finally, t minus 2 being the common factor would be written first into t minus 4. So this completes the factorization here.